Cool. 843. Guess the word. Oh, this problem is an interactive problem new to the Leetcode platform. Okay, well, I guess we'll see. Uh, People don't like it so much, so I guess we'll see. It's new to me too, so we'll see. We're given a word list of unique words. Each word is 6 letters long, and one word on this list is chosen as secret. You may call master that guessed word to guess a word. The guessed word would have type string and must be on the original list with 6 lowercase letters. This function returns an integer type, returns a number of exact matches, uh, number of exact matches while you're in position of your guess to the secret word, and your guess is not in the given word list, it will be returned -1 instead. For each test case, you have 10 guesses to guess the word. At the end of any number of courses, if you made 10 or less courses. Okay. Okay. I mean, so it's like a weird version of Mastermind, maybe. But okay, let's take a look at thing. Uh, any solution attempt to circumvent the judge? What does that even mean? But what? I don't know. So let's say you have a word list, and master is just the object that lets you do stuff. Okay. Uh, okay. So I guess this is like trying to figure out a strategy to uh, 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 figure this out. Uh, hmm. That's interesting. How many? Oh, okay. So there are 5 cases with 100 words. 100 words of 6 characters each, and okay. I mean, and each word obviously is unique. That's fine. Okay. Wow. I mean, it is something new, so I am kind of yeah, it's fun. So okay. I mean, I wonder like how I think one thing that may end up taking a bit of time is kind of trying to figure out like how complicated, like, because with these kind of strategies you could make them as complicated as you want. There's no purely like an optimal strategy per se, maybe, but definitely, I mean, the naive thing to do is that every time you get a result from master that guess, then you could eliminate words that are not possible, right? But so 6. So what does it mean? Hmm. So if this returns 3, what does it mean for all the other characters, right? Like, what can I get from this word that you know? Hmm. And so you have 10% chance of just guessing it right. You choose pure random ones, but okay. Hmm. Well, you know that I have to be in the word list, so I think the naive, or not naive per se, but my first thing I would do is kind of create that n square map of possibilities, uh, and then this kind of, I think the strategy I'm thinking toward is like, and this is kind of very generic, and I have to kind of hand wave a little bit. is to try to get as much information with each guess as possible, which is a very obvious statement, but trying to quantify that in a way given the stuff that we already guessed. Um, and I think there's some ways to kind of maybe even eliminate answers just in general, uh, like if this returns 3, what does that mean? Well, then your map, you could eliminate everything else on the word list, that because it's not just pure. Yeah, because okay, so I think we could actually just create a list of stuff. I mean, I think we have to guess randomly on the first one. Uh, maybe I'm just gonna do that then. How do you do random in Python again? Oops. Random dot choice. Okay, fine. Let's kind of start with this just to play around. You did it. Okay, well, I what? Oh, I guess the word. Oh, wait, what? Your input. Man, I don't know how this input thing is. Is there a way to test this without actually just submitting? How to create a test case? Your input, your output. I think I guess you just have to. I think there's just no easy way to run code, but okay, fine. Do we do something like this? Does that work? Maybe that's why they. Oh, I guess okay. I guess there is a way to do it, but okay, fine. For I don't know why my computer's so slow right now. Okay. So I think I'm just going to, at least for now, do a really naive thing of removing from the word list as a result. So correct. And well, okay. Guess is you. First of all, no. Ah, well, yeah, because it runs out of words. Okay, well, so we always remove G because that doesn't make sense otherwise. But then we also uh, for word and wordless, if overlap is G is equal to correct, not equal to correct. Also that remove something like that. I mean, this is where hmm, okay. Hmm. I guess it just chooses a random word every time. Okay, well, uh, okay, so that's actually that stuff and not just okay. All right, well, guess I'm gonna submit. Oh no, this is gonna be impossible to debug. I don't even know how. I mean, or even just like, uh, but I guess I could play around with this as a test case. Oh my god. Well, I said I got it right that time, so okay. Let's see. So one at the end, it's still after 10 guesses. There's still 10. Okay, so I cannot do just pure random. I had to figure out. Yeah, okay. Hmm. That time I still got a little bit lucky with just 8 of them left. Uh, I can't just go random. I have to kind of eliminate more every time. The 10 of them, then I should remain 10 every time. But huh, I had to think a little bit about how to go about choosing the word. So a lot of times it's going to be 0. That makes sense, I think. Knowing that, we should optimize for maybe okay. I mean, we have to kind of sort these things by a score, and the score in this case would be somehow like the numbers that we can eliminate. How many is it? 20 of them. Okay. That should be the same-ish. Good. It seems like since most of the time it's going to be 0, I'm going to optimize for the number of zeros. So, and there's 100 words, so that should be okay. Okay. And I'm gonna abuse some sorting. Gonna abuse some lambda functions, I think. Okay. I always forget the syntax. So, and word for word with a score. Word within the word list, say. Okay. So that will allow me to have some flexibility on the scoring. I guess should have been self.scoring, but that's fine. Word list. So the score we wanted, and this may be reversed, but that's fine. It's the number of zeros. Okay. Number 0. And, Maybe something like that. Oops, why am I doing this? Oh, get word returns a list probably. If I get word. That's not good enough. Or I got in the wrong order. Okay, well, it's still not good enough though. 1, 2, 3, 4, 5, 6, 7. Maybe it's okay. Alright, just gonna submit it. YOLO. Well, worth a shot. 1 in 4 chances. I don't know. Okay, so I mean, I think one thing we could also play around with now is modifying the score so that we, value it more. I think right now we just kind of do count, but we can probably actually use some kind of crazy overlapping thing. Even in this case, eliminate okay, but so what are the probabilities? And I definitely don't do I don't keep states, so it still has to be, I mean, it's strictly true, but no, I mean, every time we eliminate something, it's consistent. Okay, well, let's see. Man, I'm getting a little confused. But let's say we guess. Well, all the numbers that have 0, it's gone. All the numbers that it is not 0 is gone, so 76 of these are not 0. And I mean, I think I have a strategy to kind of go about this, but it's kind of tricky. I think you could create like almost like a decision tree on each path, depending on. I mean, right now I'm just being lazy on what I'm doing now, but I think you can actually work yourself backwards, being like, hey, given this is the secret word, what is the best way to go about it? And then you could calculate that for each of the words, maybe, and then kind of figure out a probabilistic score that way. Yeah. For each guess to kind of eliminate but this is just a little bit annoying to code up, but okay. Let me think. Because I think there are yeah, I mean, I think one, and I don't quite know how to do this, but if you could just eliminate a little bit like you don't even need to eliminate half, right? Because if you eliminate half, 2 to the 10th is like, 1,000, and you only have like 100 of them, right? So you don't even eliminate half, but if you eliminate like a quarter or something like that every time, then you would be able to get the answer. And I'm not, but go in details. Yeah, that's fine. Okay. Well, I know the code, but it doesn't give me the output. That's on the last case. So I was actually pretty close. If on the last case I am off by 25%, but what that was played. I don't know what. Sometimes these. I actually still am new to this. Okay, fine. Just doesn't work. Hmm. Okay, maybe I think what seems to mess up here is just that I mean, it seems to have like in the early that it goes good, but then there's 9 guesses left, or there. Yeah, I can't even see. Okay. Yeah, there are 4 guesses left for me to guess 9. The word list with 9 of them, and I really should be doing better than getting none, right? Hmm. I think my score is actually terrible then. Well, this is now deterministic, so I don't even know. I don't think that's a great way to kind of test about it, but is it the how did? Okay, well, number of words. Okay, but now it gives me an avenue to kind of explore how I want to do this a little bit. Oh. Oh, okay. Oh. And my phone is telling me it's time to stand. Okay. Because I did the reverse is equal to true thing. Okay, fine. So at the end, it is effectively random, but yeah, I guess this works. Can't believe that all these are kind of, I guess so. They're all just uniquely compared to each other. So it is. Okay. Wait, what is this now? Oh, because it's with itself. Because I was lazy. So I am doing some sort of greedy thing where I am eliminate the most elements, but then at the end, at the very end, this breaks down because, well, they're all just unique to each other. So then it ends up being like where I need to be lucky, I guess. That's a bit again. Okay, well. I mean, if I have 3 chances to guess these, well, I mean, what I also need to do is kind of randomize this a little bit. Sometimes jiggling it helps, but let's see. Okay. How do I get a random float? Zero to one. Just give me a 0 to 1. Okay. I guess random, not random. Okay, well. Okay, well, Hmm. I guess it's. I guess I get lucky enough. Um, okay. I mean, I really don't know what I would necessarily need to go for here. I mean, I have a couple strategies that I was doing, which the most is just because I noticed that zero comes up a lot when with the results. So I try to figure out. So my score function is just figure out the number of zeros that, or if I guess this and I'm wrong, who would have the most zero, so that I could generate the most. Uh, that's kind of like a little bit of naive, and then I add a little randomness at the end to kind of because sometimes you just get stuck between like you have like five choices, and then you just well hopefully you get a little lucky, and that's what I did. Not sure I like this my implementation of this. I think there might be more interesting challenges, but I think in general, I mean, I will have to absorb this. I don't know how I feel about this quite yet. It's definitely unique as a problem, and and it's it's definitely a good type of problem to ask on an interview. I think actually, in the sense that like you really get to see kind of the things that he or she, the interview candidate, get to kind of um, get to explore during like well because there's no easy right answers I don't think so well like how do you struggle with different strategies, do you play with like different do you have some kind of like branch, and I don't know, there are a lot of ways to attack this and I think that and as we saw I think it's kind of see how they think about it and what are the trade-offs, why do things work, can you prove certain things uh, but I think like, and that makes it an interesting problem to kind of probe the mind of the interviewee. But I think it also makes things a little too subjective. If like you could try like if you could try to do, or you could do like 10 different things and they're all right. Well, then like, what does it mean, right? I mean, I guess if you're just checking for pure competence, that's okay, right? But so I don't know. I would have to think about this a little bit because it's kind of like an new interactive form, as they say, and it's interesting. Uh, but okay, cool.